Good afternoon, everyone. My name is Kankanon Sakmongkoljit. I'm a master degree student in geotechnology from Kankanon University. Today, I would like to give a presentation on the topic of multi-criteria flood susceptibility assessment using remote sensing and GIS-based approaches in Chi River Basin, Thailand. Let's start together. Nowadays, floods perceived to be a frequent natural disaster inflicts damage worldwide, including losses in the housing and agricultural area. Flood disasters caused by both natural and anthropogenic influences with less economic, agricultural, and social losses. However, there is no single solution provided in terms of the flood management plan, and the warning system is still a real-time fuzzy warning. So, the flood susceptibility mapping is a tool for spatial water management to enhance the flood prevention and mitigation strategies. The Chi River is the longest river in Thailand. The study area is the part of the river basin, which we call as CRB, consists of the 17 districts with a total area more than 3,000 square kilometers, which flows to the several provinces in the northeastern regions of Thailand, including Sarakham and Northeast Province. The floods often occur in the basins, such as the flooding from the influence of the tropical storm Senka in 2017. The study aimed to assess hydrogeomorphological factors which influence the occurrence of the flood. The spatial flood susceptibility map of the CRB in Sarakham and Northeast Province was developed and evaluated by utilizing the analytical hierarchical process or AHP and divided into the different flood risk levels spatially. Now, let's move on to the methodology. This study applied a GIS-based and AHP technique for generating the flood susceptibility map. The data has been acquired from the various sources, such as the satellite images and government organizations for delineating the different flood zones in the CRB. ArcGIS software were used for the CRB delineating. Preparation of the mathematical map, which is generated through the ArcGIS tool, consists of the hydrology tools, buffering function, digitization, density tool, and raster calculator for overlaying map. The Landsat 8 images with the 30-meter resolution from the USGS database has been acquired for a supervised land use classification technique in the EarthDAS imaging software to delineate a land use map of the study area. The AHP, as among other multi-criteria analysis methods, is efficient, cost-effective, and less time-consuming methods. The AHP method dividing the problem into the sections in the form of hierarchical model by imitating the human brain complex concepts to achieve the right decisions based on the information available. This slide shows the three main steps of the AHP consist of the hierarchical classification, pairwise comparison, weight, and length. The pairwise comparison process is the main part of the AHP technique that assigns the numbers for representing the data to determine as parameter weight. The value and criteria of the parameter are given for indicating its relative importance between two parameters. The next step is the weight arithmetic means for calculating the eigenvalue. The goal of this process was to measure the weight in a pairwise comparison method using the mean-low approach. Finally, we check the consistency of the weight with the CR value. If CR less than 0.1, it means a good weighting. Now, let's turn our attention to the result. The results of this study consist of the three sections. The detail of each section is explained as follows. The first section is thematic maps. This slide shows the total 7 fast causative parameters. The detail of each parameter is discussed as follows. The distance from the river considered the most influential factor for the flood disaster in the study area with a normalized weight with a 0.3. Elevation is generally low in the middle of the area along the flat plane next to the shear river main stem, as illustrated in the figure B with the normalized weight of the 0.2. Geology influences flood disaster in terms of its permeability. Geologic distribution of the study area is illustrated in the figure C, which has a normalized weight of 0.1. Soil type: the clay content in the soil causes a lower infiltration rate, which enhances the flood risk of the area, as shown in the figure D with the normalized weight of the 0.1. Land use: the CRB land use map is present in the figure E with the normalized weight of the 0.09. Pavement in urbanization's land use trend to the cause flooding. The net density map is shown in the figure F with the normalized weight of the 0.06. And the last one is the geomorphology. The floodplain along the main stem has the highest flood risk that the other landform in the CRB, illustrated in the figure G with the normalized weight of the 0.04. All flood causative parameter maps were all rated by utilizing the weight linear combination methods in ArcGIS software to generate the flood susceptibility map. Right, let's move on to the second section, which is an assessment of flood susceptibility map of the CRB. Flood susceptibility map was categorized into the 5 different levels using the natural breaks method that's shown on this slide. As you can see, the very high flooding mostly concentrates along the shear river floodplain in the central part, indicated in a red area on the map. In contrast, the dark green regions on the map represent the very low flood susceptibility, spreading on the high elevation regions on the northern, southwestern, and the southeastern part of the study area. The flood susceptibility map has been evaluated for its accuracy and reliability by comparing it with a historical flood data. The combined historical floods of the study area in the 2005 to 2016 had been acquired for the Geoinformatics and Space Technology Development Agency of Thailand, or GISDA, and compared with the flood susceptibility map of the study area. The accuracy of the map to a correct determination of the flood and non-flood area as compared with the observation data. The map had an accuracy of 73% according to the Bionic classification test. Just a quick recap of my main point in conclusion. 7 hydrogeomorphologic parameters have been determined as the flood causative parameter in the CRB. The highest normalized weight in the study is a distance from the river, followed by elevation, geology, soil type, land use, the net density, and geomorphology, respectively. The fluvial flood is the dominant flood type in the study area because the weighted parameter on the flood susceptibility is a distance from the river. And finally, the ASP method is the well performed for the flood susceptibility mapping of the CRB, which can be utilized in other basins. Although this study has confirmed by a good accuracy, there are remarks, uncertainty, and limitations that need to be addressed for the study. A different list of parameters for flood susceptibility assessment should be determined according to the physical specific characteristics of each basin, as well as the social and economic aspects. All parameters were considered as static parameters, which are not changeable or not right to change through the time, reflecting the physical flood susceptibility of the basin. Rainfall is a factor that has been excluded in the study since we consider it a dynamic parameter which can change rapidly through time. That being the presentation to the end, does anyone have any question or comment? It would be pleasant to share with everyone. Thank you for your attention.